Hello everyone, this is lecture 240. In this lecture, with the help of example, I will try to make you understand how to find the absolute maximum bending moment. So for this concept, we have already derived one article. So we'll follow the stepwise the calculations so that you can visualize and understand very smoothly. So let's say take example, the load system shown like this moves left to right on a girder of 10 meter span. Find absolute maximum bending moment for a girder. This type of question can be asked in your examination, can be asked in your BTech exam, yeah, somewhere else it can be. So let us begin. Let us see, observe the loads. This is 100 kilonewton. These are in kilonewton. You put kilonewton. These are in kilonewton. These are in kilonewton. Randomly you can have a load 120, 60, 150, 70. This is a wheel load. So these are at a distance of 1 meter, 0.5 meter and 0.5 meter. So let us observe first of all how to you observe to find out the maximum bending moment. For the maximum bending, you look on the loads. Loads are 120, 60, 150 and 70. So your mind will go for 150 load because this is the maximum load. If this load is somewhere in the near the center of you can say of span or girder, then you will find the maximum. So by observation, your mark load are 150 kilonewton because this will give you maximum absolute bending. So the absolute maximum bending will occur near center of girder. The mark load and the CG of total load exist at a equidistance from CG of girder. This is the point. Means the mark load and CG will be equidistant. CG of load will be equidistant from the center of girder. This is our fundamental things which we have to keep. So for step 1, visualize which load gives you maximum moment. So by visualization, we are getting 150 kilonewton will give you maximum bending moment. So this will be near center of support. So step 2, by observation, 150 kilonewton will give maximum bending moment near CG of girder. So this is possible. So step 3, find CG of load system with respect to load 70 kilonewton, because this we cannot start from 150. We will start from 70, which is the nearest load. So take the CG from this point 70 kilonewton. So we are taking 70 kilonewton with respect to 70 kilonewton. We are trying to find out the X bar, that is where the lies centralized. So summation W X bar equals to 70 into 0 plus 150 into 1 plus 60 into 1.5, because this is 1.5 from this distance. We are measuring from this distance. This being maybe distance, this distance, this distance, this distance and this distance. For this load, this is this A1, this is your A2, this is your A3. So A1, A2, A3. A1 equals to your, for this first point, this is 0, this is 1, this is weight 1.5 and this is 2. So you are getting 0, 150, 19 plus 240, 480 and X bar you are getting 480 divided 4, that is 1.2 meter. So this is 81.2 meter. So load is at this point. This is 1.2 meter from here. Please observe it. This is 1.2 meter. So the distance between the CG load and 150 kilonewton load is only 0.2 meter distance. So this half divide 2, that is distance between the CG of the load and the mark load is 0.2 meter. So this will be half. CG of girder is 5 meter. Now put mark load at a rate of 0.1 meter from the CG of gutter. तो 0.1 मीटर आपको शिफ्ट करना होगा किस तरफ, राइट हैंड साइड, क्योंकि CG यहाँ पर है आपका, तो CG will shift somewhere here, so your load, mark load will go this side. So mark load go this side, so what will happen? 0.1 meter, that is 0.1 meter from CG girder, so that summation of WCG lies equidistant from the CG of girder. This is your important point, step number 5. So let us rub it and let us visualize where we put the load. So we'll put the load at a distance of from the center. This your center may be like this. So this is your girder. Suppose this is your girder, and this is your central line, that is 0.5 meter. This is also 5.5. This is 5 meter, and your 150 kilonewton load will be shifted by 0.1 meter. So 0.1 meter, and your CG will be like this. So distance is only 0.2 meter. 0.2 meter. So this is shifted like this from CG. This is 0.1 meter. 0.1 meter. 0.1 meter. So now the distance of this load will be from here. How much? This will be your 5.1 meter. This is 5 because this reach is this is your center C. So this is 5.1 meter, and this is your 4.9 meter. And let's observe what is the load over here. This load is 70 kilonewton. This is at a distance of 1 meter. So this distance will be how much? That is 4.9 minus 1 equals to your 3.9 meter. We are concerned with this load because we take the moment with respect to this load जो 150 किलोमीटर के रिस्पेक्ट में ही हम मोमेंट फाइंड आउट करेंगे. दिस इज योर BA and this is your BB. So if you take this is your we are taking this is summation W. This is summation W, and this is your mark 70 kilonewton load, and this is your 150 kilonewton load. This is your 150 kilonewton load. So let us find out the BA and BB. From the conditions we can have. So BB, if you see, this is at a distance of this is your 0.1, this is 0.1, this is 4.9, this is your center, this is 5, and this is your 0.1 meter. This is 0.1 meter. So this is 4.9, this is 0.1 meter. So distance from here to this is 5 meter. This is 5 meter. This is 5.1 is center. No, 5.1 is this. So 5.1 is this. So this is 5 minus this is 0.2 meter. 5.1 minus 0.2 meter. So this will be your load will be at a distance of this is 9, this is 4, this is 4.9 meter. 4.9 meter, this is 4.9 meter, both sides, and 0.2 meter is in between. 0.2 meter in between, and from this load, this is something like this. So, if you want to find out the BA and BB, how we'll find out the BA and BB? Let us see how we'll find out the BA and BB. BA and BB. The load is something like this. So, BA is 4.9. You forget this thing. This is your BA, into this distance is 4.5. That is BB into, you can say BB into 10 meter equals to, you are taking moment about A, and that is sigma W into 4.9 meter. This total load. But we are putting the load in these conditions so that we can get the maximum. So this is sigma W. Sigma W is nothing, 120, 60, 180, 70, 250, 100, 400. So 400 into 4.9. So your VB equals to 4 into 400 into 4.9 divided by 10. So this is your 4.9 into 4. This is 4.9 into 4. This is 4.9. 4 into 40. 4.9 into 40. So this is your 196 and BA equals to 400 minus 196. So this will be your 400 minus 196. This is 204. So BA is 204. So we have got the BA and BB. This is 204 kilonewton, and this is, now let us find out the maximum absolute maximum with respect to 150 kilonewton load. So take the moment of the right hand side, maximum absolute bending moment is taking moments of forces to the right hand side of marked load. Your marked load is 150, so we are getting like this. This is your bow, this is your marked load, this is 150, and this is 1 meter 70 kilonewton. This is 3.9 meter, and this is your 4.9 meter. This is a BB equals to 196 kilonewton. So you are taking moment about this. So moment will be BB into 4.9 minus 70 into 1. So this will be BB 196 into 4.9 minus 70. So let us find out this value. So this will be 196 into 4.9 minus 70. So we are getting 890.4. This is 890.4 kilonewton meter. This is your absolute maximum bending moment. So I think you have observed it step by step, and you can always find out the absolute maximum for any given rolling loads. If it is said, if it is asked in the question with respect to some load, then you find with respect to that load. If it is not asked, then mark the maximum load and do in the same way which I have done step by step. Thank you for being with me. Thank you very much.